Okay, I thought I'd do a quick video for you to help you out with the material that is associated with homework assignment 6.7. And this is graphing quadratic equations and quadratic functions. So just a little bit of review. If I have something like this, y equals 2x plus y, or plus 1, this is a linear equation. And it happens to be in slope-intercept form. This graphs as a line, right? Right here at 1. That would be my y-intercept. It has a slope of positive 2, so it is heading in that direction. That is a line. Now, quadratic equations are different, and they do not graph as lines. Okay? Here's a quadratic equation. Why is it different? Well, because you have a variable term that is squared. And when that's the case, this is going to graph as a parabola. That is either a bowl that opens up or a bowl that opens down. Okay, so this is going to graph as a parabola. And again, because it has this square term, and we'll see how that bears out in a minute. One other thing I'd like to point out is this is a quadratic equation. If I put it in these terms, this is a quadratic function. These are identical. Okay, so y is the same thing as f of x. Sometimes they're going to talk about functions, in this case quadratic functions. Sometimes they're going to talk about them as quadratic equations. But these are absolutely, completely, and totally identical. Now, quadratic equations or quadratic functions have a standard form, and this is a standard form. Okay, so where y equals ax squared plus bx plus c. A and b are the coefficients of the square variable term and the non-squared variable term, and then c over here is a constant. Okay, there's a lot of information in that, just like there is in the slope-intercept form of a linear equation. And some of that information is that, for instance, c is the y-intercept. So when we're going to graph this quadratic equation here in a moment, and when we do, we're going to see that right here is one of the points, the place where it hits the y-axis. There's the intercept right there, and that c gives us that. And now sometimes notice that this term here is not part of this equation. So each of these are going to look a little bit alike. If it doesn't have this, it is not a quadratic equation or a quadratic function. It may or may not have these other two terms. It just depends upon the particular parabola itself. Now, if we look at the coefficient of the square term, a, there's some more information we can get from that. If a is positive, the parabola is going to go up. So this parabola here is going to open up. If a is negative, it is going to open down. Okay, so just keep that in mind, and we're going to see that borne out here in just a minute. Okay, so let's graph this quadratic equation. Let's see how that is going to play out. Now, a couple different things can happen on your assignments. On some of the assignments on 6.7, some of the exercises, you are given values for x already, and you just have to find values of y. So let's assume that that's the case here, and I'm just going to pick 0, 1, negative 1, 2, and negative 2. Okay, for lack of anything better. So if you were given these and asked to find the corresponding values for y, and then you would graph those points. So in this case, if x is 0, y is 1, right? That whole term becomes 0. If x is 1, then 1 squared is 1. 1 times 2 is 2. 2 plus 1 is 3. Negative 1 squared is 1. 1 times 2 is 2. 2 plus 1 is 3. Okay, 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9, and it's going to be the same thing here. Notice that there is a pattern there. Not always, especially if you have that middle term which is missing in this one, but there it is. Let's plot these. There's 0, 1. I have 1, 3, negative 1, 3, 2, 9, and negative 2, 9. So let's take a look at how this is going to graph just like that. Okay, notice it is a parabola. It's not a line, it's not something else, it's a parabola. Okay? All right, well, let's take a look and see what happens if that coefficient is negative. So I'm going to do away with this one, and we're going to make this negative, and we're going to, instead of a quadratic equation, we're going to make it a quadratic function. Remember, they're absolutely the same. They're identical in every way. And let's just use the same values for x that we used before. So if I put 0 in for here, I'm going to get 1 again. All right, so there we go. That's where it's going to change from there, however. If I put 1 in, okay, 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 plus 1 is negative 1. It's going to be the same thing here. When I put 2 in, 2 squared is 4. 4 times negative 2, negative 8. Negative 8 plus 1 is negative 7. It's going to be the same thing here. Okay, so now let's look at how this thing is going to graph. And I'll use black just so that we can keep these separate and apart. There's the same spot there. Okay, the same y-intercept, but I have 1, negative 1, negative 1, negative 1, 2, negative 7, 2, negative 7, and negative 2, 7. So I have this parabola here, okay, that opens downward. Why? Because the coefficient of the squared term, the square variable term, is negative. Okay, let's see it. So it bears that out. All right. Okay, so just notice how that works. Let's do one more just so we can, this may be a little bit more complex, just so we can see how this thing plays out. And when you do this yourself, you just need to be really, really careful. So let's do another quadratic function, and let's assume that it is negative x squared plus 2x plus 4. Okay, and so I'm going to ascribe values of x. In this case, I'm looking for f of x. And again, 0 is always a good place to start. So let's do 0 and 1 and negative 1, and we'll see what happens from there. So if I put 0 in, both of these become 0, and the value of the function is 4. If I put 1 in, I have 1 squared negative 1 minus 2 plus 4 is going to give me, if I have positive 1, it's going to give me 5. Okay, so negative 1 plus 2 plus 4 is positive 5. If I put negative 1 in, I'm going to get 1. Why? Because this term here becomes negative. This is still going to be negative 1 minus 2, okay, plus 4 is going to give me 1. If I put 2 in, I'm going to get 4. If I put negative 2 in, I'm going to get negative 4. If I put 3 in, I'm going to get 1. If I put negative 3 in, then I get negative 11. When I start getting there, I just need to stop going in that direction. And if I went back to 4, I would get negative 4. Okay, so let's graph this and see what it looks like. I have 0, 4. I have 1, 5. 1, 5. I have negative 1, 1. I have 2, 4. I have negative 2, negative 2, negative 4. I have 3, 1. Okay. I have 3, 1. And negative 3 is down here, it's negative 11. Okay, and I have 4, negative 4. Okay, so here's my vertex. Notice it's not on the y-axis. It's over here. So there's my parabola. This term here is going to offset it generally to one side or the other from that. But notice I have a negative 1 here, so it opens down. Okay, so and again, if you start getting things that are off the grid, quit going in that direction. There's no point, since I got such a big number for negative 3. Negative 4 is going to be even have a larger absolute value. So let me start heading the other direction with it and go back from 3 to 4, and even 5 might be on there. It might not be. Okay, and actually it won't be. But okay, so all of them are the same like that. You're either given x values and you have to find the corresponding y or the corresponding f of x value, you plot those, or you have to give x values yourself and then find the corresponding y or f of x values and plot those. That's all there is to it. Okay, easy peasy, get it done. All right, cool. Bye.